North America is increasing the use of ethanol as a substitute for the gasoline additive MTBE. As the cost-effectiveness of this technology increases, industrial companies in the USA and Canada are very interested in commercializing the technology and producing ethanol from grain or biomass. The majority of plants in the North American ethanol industry use corn as the feedstock for their production processes. All current plant expansions, plants under construction, and most plants in the planning stages will use corn as their feedstock. Other alternative feedstocks include the use of milo, cheese, whey, beverage, barley, and wheat, as well as the use of potato industry waste, forestry and wood wastes, rice, straw, and municipal wastes. The Americas continue to be the world's leading ethanol production region, with no indication of change in the foreseeable future. The total production in 2003 is forecast to reach 8 billion gallons, which is 66% of the world output. The world leader in the past 30 years continues to be Brazil, with 5 billion gallons in that country's forecast for 2003. At the peak of ethanol production in the early 80s, Brazil had 40 to 60% of its manufactured vehicles fueled by ethanol. The total U.S. production in 2003 is expected to reach 3 billion gallons, with a projected new construction and expansion spending of $4 billion. During the rapid development of today's ethanol industry, SMAR has established itself as a company that can provide a variety of automation and control solutions. For over 30 years, SMAR has developed products for the ethanol industry and has achieved the leadership position in this market. SMAR is present in 85% of the South American ethanol plants, developing automation solutions for all stages of the production process. There are presently 57 operating MFGE, or motor fuel grade ethanol plants in the U.S. By 2005, there will be 104 operating plants. The industry will need up to 2,000 skilled employees to operate these 45 to 60 new ethanol plants. Most of these plants will be located in rural agricultural areas. The design of a successful MFGE facility requires a clear understanding of the economic sensitivities. First, feedstock costs comprise over 60% of the total cost. Second, energy consumption must be reduced to less than 40,000 BTUs per gallon of product. The modularity of the SMAR control system permits incremental implementation and provides an easy approach to modify and expand the individual control loop strategies in a simple and unprecedented manner to improve feedstock conversion efficiency. Unique to SMAR is the DT302 concentration and density transmitter applied to determine a hydrated alcohol degree of 90 to 100 GL, an anhydrous alcohol degree of 90 to 100 GL, and a level density and interface measurement of 560 to 1,000 kilograms per cubic meter. In existing facilities, control systems have been applied and installed using conventional DCSs, distributed control systems, or PLCs, programmable logic controllers, to satisfy the process control requirements. These DCS and PLC systems address the total facility requirements. Unfortunately, they're a global concept, and a malfunction of any aspect of these systems, even minor, can affect the total system operation and on-stream available time. Plant maintenance personnel must be extensively trained in many technologies to be qualified to quickly diagnose malfunctions and effectively perform necessary repairs to minimize the effect on production. SMAR automation solutions allow for some key issues to be better addressed. System 302 provides a single loop integrity, and redundancy can be provided to limit the effect of a malfunction, and permits restoring operability with minimal or no intervention from the operator. Because SMAR provides open architecture solutions, operational staff can easily perform simple maintenance functions. Arolco Distillery has daily ethanol production in excess of 112,000 gallons. This facility utilizes a cyclohexane process and a SMAR system for its automation and control. Conservative estimates reflect an increased annual output of approximately 14%, 19 to 22 million gallons, after implementation of the SMAR system.
I have the CD600 controlling both devices. I have the LD301, which controls the steam level and pressure. I have FY positioners that control the valves, and the DT301 touche, which controls the must and the brakes. Despite the employees' efforts, they couldn't supervise everything at the same time in terms of the column temperature. SMAR's automation system achieved this since it automatically corrects everything at the right time. The supervision system helps us in the complete monitoring of the distillery. In other words, you can view the entire distillery on the computer monitor. Presently, I think it would be almost impossible to operate at a productivity and product quality assurance level if we didn't have automation.
Moema Distillery utilizes System 302 in several different applications. Early indications of this implementation's impact show that System 302 has increased production by more than 25%. Total plant output is expected to exceed the 2002 production rate of 27 million gallons.
We have installed at Moema Mill approximately 110 transmitters from the LD301 and 302 lines. We have 87 FY290 and 302 positioners because we have a plant in Fieldbus. We have 4 PLCs installed, one at the distillery's new plant, which is a glycomonoethylene plant, apparatus 4, and we also included the other 3 devices, all in PLC.
Santa Elisa Company is well known as one of the world's largest ethanol producers. The company utilizes 3 different dehydration technologies, including conventional monoethylene, glycol screen, and molecular screen. The facility will produce over 72 million gallons of ethanol in 2003. Santa Elisa has looked to SMAR for process and automation solutions since 1997. Their technology, and subsequently System 302, has been implemented in many primary areas, not only in ethanol applications, but in sugar and biomass energy production as well.
The plant is presently composed of SMAR Fieldbus systems and CPUs from the SMAR LC700 line. We also count on a supervision system with 25 IMAX and Endosoft stations monitoring the entire plant. We also have approximately 250 instruments controlling level, pressure, and temperature transmitters and density meters installed throughout the entire plant. Besides achieving a balanced process, you are also able to reach the plant's maximum efficiency and productivity, and with great comfort as well as reliability in the operation of the system.
For over 30 years, SMAR has been a leader in the process automation industry. SMAR was the first to develop and introduce key milestone elements that have made and continue to make Foundation Fieldbus the digital technology of the future.